Okay, so here we've been presented with an equation where you can quite clearly see that this is effectively what would be described as a, chemically at least, it would be described as a complete combustion reaction, right? So let's look at how we would go about balancing this equation. So the first thing I'm going to do is I'm going to work on auditing both sides. So you've got the reactant side and the product side. We're going to look at, well, what's the occurrence of each element present? What's the occurrence on either side of the equation? So for the reactant side, we'll mark that as being the left-hand side, right? Because obviously it's on the left-hand side. So I'll just use LHS as the abbreviation. And for the right-hand side, RHS, right? And so on the left-hand side, we're looking at effectively carbon, right? Hydrogen and oxygen, right? So how much of each of those do we have on the left-hand side? Well, we've got 2 carbons, we've got 6 hydrogens, as you can see, and oxygen occurs in 2 species, right? So it occurs in the molecular oxygen. It also occurs in the this molecule we have here. So if we look at what this could be, and by the way, when you look at this could actually be 2 different things, right? So I mean, it's not really gone into it's almost irrelevant to specify what exactly it is, but it could be an alcohol, it could be something else, right? So it could be so this is within the context of like isomerism, right? But both of those could actually like, you know, could take place could partake in this kind of reaction. So but this could be so it could be this, right? So that's, of course, we know that's basically ethanol, right? But it could also at the same time be, if we go COC, right? And then H. Yeah, put that, and then H, right? So it could also be this. Now the thing is, regardless of whether it's ethanol or well, there's an abbreviation we can use for this. We can just call it DME, right? DME, right? I mean, DME is effectively dimethyl ether, right? So let me just fix this pen. So okay. Dimethyl ether, right? But this is, you know, this is kind of outside of the main focus of this, so I'm literally going to move this. Just going to move this to one side. So that's the. So anyway, focusing on the actual balancing of the equation. So for oxygen, right? So oxygen would be 1, right? And no, wait. So I got a bit distracted with the comparison. So oxygen would be so it occurs, as I said, it occurs in both species. We've got it here in the well, C₂H6. I just call it C₂H₆O, and in the O2 as well. So it occurs 3 times, right? And on the right hand side, so CHO, if we do that, we can see it occurs in the CO2 once. For as far as hydrogen, we've got H2, right? So we've got 2. Wait, did I just? Yeah, let me just fix this. So I'm thinking of 2 things at once, basically. So occurs once, H occurs twice, and oxygen, you've got it occurring in both species, so O2 and O, right? So we've got effectively it's occurring 3 times. Now, if we compare the left-hand side and the right-hand side, what can we see? We can see that in some sense it seems as though the oxygens are balanced, but everything else isn't, right? And got to ask ourselves, well, how can we go about fixing that, right? One of the first things I'm going to do in terms of approaching resolving that is effectively I'm going to try and balance the carbon first. So carbon occurs in the CO2 on the right hand side, and it occurs less, as you can see. We need to, so what I'm going to do, I'm actually going to put a 2 in front of the CO2 in order to get this to be 2. But we know that that's also going to affect the oxygen, the quantity of oxygen. But let's see what that looks like as an equation. So right, and if we take a look at basically auditing this, what do we get? Well, for the left hand side, we didn't actually change anything, so effectively what it was before is what it's going to be. It's not going to change, right? So it's going to be 263. And on the right hand side, however, it's going to be a bit different. So on the right hand side, we're going to have effectively, okay, so 2 times, wait, let's actually write out the C₂H₆O. So on the right hand side, we've got 2 times C, right? So that's going to be 2. For oxygen, it occurs here, right? So 2 times O, that's going to be 4, but then we have to do the +1, right? So it's going to be, actually it's going to be 5, right? And then with the hydrogen, it just occurs there, right? So that's going to be 2, right? So what we've been able to do, although we've now been able to balance the carbons, now the oxygen, which previously seemed balanced, is not anymore, and hydrogens are not balanced. So we need to take some level of action to try and make the hydrogens balance. And the reason why I'm going to focus on a hydrogen at this stage is because, as you can see, oxygen is on its own. Because it's on its own, it's much easier to balance that at the end, right? Rather than trying to do it at the start. Because when you do put a number there to try and balance the oxygen, it's not going to affect any of the other, the quantity of any of the other elements, right? So I'm going to leave that to the end. I'm going to focus on the hydrogen first. And when we're looking at that, so what's the multiplier, right, to get this to be that? So we can simply, you can work that out from visual inspection, but I'm just going to do the calculation. So so 6 divided by 2 will give you 3, right? So this tells you that the coefficient we need is a 3. So specifically in this case is a 3 because we've got, as you can see, H₂O, right? So H2 is only occurring in there. So if you put a 3 in front of that, of course that would then be it would be 6 hydrogens, which would then balance with the left hand side. So let's do that, and I'm going to just draw out what the write out what the new equation is going to look like. So C₂H₆O plus O2, and then that goes to 2 CO2 plus 3 H₂O, right? And actually, if we do our auditing process again, so I'll just use, so for the left hand side, what we're going to get. We didn't change anything, right? For the left hand side, we didn't change anything just now, so there's not going to be any difference between this and what we got for this, so that's going to be quite straightforward. So that's just going to be 2, 6, 3. But then for the right hand side, of course we added the 3, right? So it's going to be a bit different. C₂H₆O. Now we have to give regard to the fact that we added a 3 here, but as far as the species containing carbon, which is only CO2, it's the same, right? 2 CO2, and that's the only one that contains carbon. So carbon's not going to change. It's going to be the same as it was, but oxygen, obviously H2O contains hydrogen and oxygen, so that's going to change both the hydrogen and the oxygen. So we know what we were aiming for here, and it's what we, it's going to be 6, right? 3 times 2, right? So, but for oxygen, we have to consider this and add it to what we've got over here. So we've got 4, so it's going to be 4 plus what we've got here. So that's going to be 3 times 1, so it's 4 plus 3, right? Which is going to give us 7, right? Right. Okay, so how do we then balance that? Because now we need to balance this oxygen. We've got a 3 and we've got a 7, right? So what actual increase do we need to get from here to here? So we need to increase by 4, right? Our increases that we need is actually 4. If we can increase the number of oxygens by 4, we can get the correct number of oxygens at the end. And how can we achieve that? Well, we've got, as you can see, we've got O2. If we put a 3 in front of this O2, we're going to increase the number of oxygens by 4, aren't we? Right? So simply put, if we put a 3 in front of the oxygen, let's see what we get when we do that, right? So C₂H₆O plus 3 O2, and then it goes to 2 CO2 plus 3 H2O, right? And so obviously then if we look at left hand side and right hand side, so C₂H₆O and C₂H₆O here. So on this side, we put the 3 in a place where the number of carbons would not be affected because we didn't actually change it. It's for this species, which is the only species on the left hand side that contains carbon. It means it's going to be the same because we didn't change it, so it's going to be 2. For hydrogen, similarly, we didn't change anything with regards to the only species on the left hand side that contains hydrogen, so that's just still going to be 6. But for oxygen, as we said, so that's going to be 6 from here. So it's 3 times 2 is 6 plus 1, so that's going to be 7, right? And on the right hand side, if you remind ourselves, what we have here is exactly the same as what we earlier had. So as far as the values accounting, kind of that auditing process, we're going to have exactly the same. It's going to be 2, 6, 7. But now, if we compare the left-hand side and the right-hand side, what do we find? We find that we actually have now a balance as far as all of the number of the occurrence of the elements on both sides. And because of that, and because also, remember, the question specifies, please only use whole numbers when balancing the equation above. And if we check what we've done, we've got only whole numbers, right? So we used a 3, 2, 3, right? So this would be effectively our balanced equation, okay? And so you can go back to the top and kind of just put that in, right? Right. Okay.